In this video, we're looking at the proper way for us to write our equations out when we're given a worded question. Okay, so when we're given a worded question, there's two steps we need to take. The first is to identify our pronumerals, so any variables we're going to use, and then we can write out our equation, and often we can then solve it. But we need to write our pronumerals out and write them nicely, and then also write our equation. So this is our first question. We've been told that a tree's been growing at a rate of 70 centimeters a year, and then asked to find what its height would be after 10 years. So first step, we want to identify the pronumerals, and we're looking for height. So we're going to just write that h equals the height of our tree. Now we could find other pronumerals, but we've been given their values, so we're going to forget them for now. And now we can start writing our equation because we have our variable, a pronumeral, and we've also got our two numbers we need to worry about. So we're going to write now that h equals, and now we know our tree is growing 70 centimeters each year. So it's going to be 70 centimeters times 10 years, so times this 10. And then we can solve it. So this is a normal sort of question. So our height would be 7 meters. So now we've solved our worded problem, except because it was worded up here, we need to then give an answer down here, which is worded. So we could say the tree is 7 centimeters tall after 10 years. We could even write F growth. So we just need to rephrase this beginning question, but giving our solution in there as well. And it's always a good idea to underline your answer. Now this is our second question. It says, if the area of a triangle is 30 square centimeters and the base length is 12 centimeters, find the perpendicular height of the triangle. Now this question is using a formula we know. Area equals half times base times height in a triangle. Now because we're looking at how we can set out our equations really nicely when we're using worded ones, we can then define what each thing means. So we could write A is the area of a triangle, B is going to be the base of triangle, and H is going to be the perpendicular height of a triangle. Okay, so now we can go in. We are looking for the perpendicular height of our triangle. So we can either substitute our values in here straight away, or we could use our knowledge of solving equations to make h the subject of our equation. But let's just go straight away and substitute things in. So we're going to get 30 centimeters squared equals 12 times 12 centimeters times our height. So now that's going to be 30 centimeters squared equals 6h. We divide both sides by 6. We're going to get 15 equals, sorry, by 6. We're going to get 5 equals h. And then we can fix that to be 5 equals h centimeters. And then finally, we can write the answer. The perpendicular height Okay, and it's important to remember that we write out our full answer when we've been asked in words. Now it's your turn, have a go at this question. Okay, so the important variable to define here is the hours, because that's our thing we're looking for. So we can write h equals hours of car running. Or that it will run. Now we can put it into an equation. Now the car was filled with 40 litres, so we start with 40 litres. So I'm going to write 40 litres. During the trip, 8 litres of petrol are used every hour. So what we're doing is we're taking 8 litres away every hour. So every hour we're running the car, we're losing 8 litres. We want, and now this is an expression which represents what's there, but we want the equation so we can solve it. We want to ask how long will the car run before the petrol is used up. So in other words, when this is going to equal 0 liters. So now we can solve this like we would a usual equation. I'm going to start by subtracting 40 liters from both sides. So I'm going to get minus 8 liters worth of hours. And just to remove confusion, I'm going to write it like this. Divide both sides by minus 8. We get that hours equals 5. Then finally we write out the car will run for 5 hours. And that's our solution.